Alright, we're going to start off with laws of indices this time around, and just a quick run through. So we did the first two earlier. When you're multiplying terms, same base, same variable, different power or same power, we add the power. So this is 7x to the 7 times x squared will give you, we all know you have to add the power, so this would be x to the 9th. 2 to the 5th times 2 to the 3rd will give you 2 to the 8th, and that would be 2 times 2 times 2 continuously. And then we did division. When you divide, you subtract the powers. So this would be 3x to the 3rd divided by x to the 5th. This would be x to the 3rd minus 5, which will give you x to the minus 2, which will take you to this law, and you will see what this law states. This law states whenever you have a negative power, it will be 1 over that term to the positive power. So that is this law here. This division here, this would be y to the 3 minus 3, which is y to the 0, and then you'll see this law. Anything to the 0 power is equal to 1. And then we have this law here. When it's in this form and you have to multiply, there's a bracket between the powers. It means that you have to multiply the powers. So x to the second power outside third power would be x to the 2 times 3, which is 6. Again, 2 to the 3rd and 4 outside would be 2 to the 3 times 4, which is 12 power. Alright, that's how that is work. And as I said earlier, anything to the 0 power is equal to 1. 109 to the 0 power is equal to 1. X square y to the 0 power outside, this is this law up here. You have to multiply inside. X square would be times 0, y to the first power would be times 0. This would be x to the 0 power times y to the 0 power, which is equal to 1. Not a big deal there. And again, anything to the negative power is equal to 1 over that same term to its positive power. So if we had y to the minus 5th, will be 1 over y to the positive 5th. Simple as that. So you need to remember these laws. They are very important when working other topics in mathematics. The laws of indices governs the power and multiplication of certain sources. So you need to remember them. What about this law? When there is a fraction in the power and the numerator is 1, that will be the nth root of that term. So we have here 25 to the 1 over 2, or 25 to the half. That there will equal to 1, the square root. You don't have to put the 2 here. Okay, you see the n there. This n cases for when the power is greater than, when this number is greater than 2. So you don't have to put the 2 there. We know what's square root. It will be square root of 25, which is 5. We all know that. And then this will be the cube root of 27. And we all know that is 3. 3 times 3 equals 9. 3 9s 27. And we come down to the bottom here with the final law of indices. Any term to the m times n divided by n power is the nth root of that term to its power. So we have this example here. 4 to the 3 over 2 power. That will be the square root. The 2 is at the bottom, so the 2 comes there. You see the n is at the bottom, so the n goes there. Square root of 4 to the 3rd power. 4 is 16, and 4 16 is 64. So this will be the square root of 64. And the square root of 64 is 8. So that's the laws of indices for you. There are other applications for the laws of indices, and here you will see a few. I'm going to work them out here. So we have here 64 to the power x equal to 16. when you see problems like this, you'll try to lower these numbers to its lowest power or lowest form, added a power. Okay, we know that. Let me start over here. We just figure out that 4 to the third power is equal to 64. So this would be 4 to the third power, and you have x in the power 2, so that would be 3x is equal to, we know that 4 to the second power is 16. So when these bases are the same, when you get them like this, you can drop the base, and 3x is equal to 2. X will be equal to 2 over 3. That's how these problems are solved. We're trying to get them to the slowest base, and then we drop the base and we work on the powers because the variable is in the power. So this is how you do it at all times. So let's go on to the second one. We have 625 to the power p minus 2 is equal to 5 to the power p minus 2. We know the lowest power for 625 is 5 to the what? 5 5 is 25, 525 is 125, and 125 is equal to 165. So we know that for sure. So this would be 5 to the fourth power, 525, 5 to the fourth power, times p minus 2 is equal to, but we already have 5 as the base over here, 1 plus p. So we have the bases, so we can drop the base. 4p minus 2 is equal to 1 plus p. When we expand here, 4 times p and 4 times 2 is equal to minus 8 plus p plus 2 there, and we take over the 8 and bring over the p. 4p, this minus this p comes over, this goes over, and this comes over. It becomes a minus p, and this becomes 1 plus 8. Sign changes. So 3p, 4p minus p is equal to 3p is equal to 9. P will equal to 9 divided by 3 is equal to 3. So we found what the variable is equal to. So let's go on to the one at the bottom. Now this is very nice. I like this one here. This shows, the bracket shows a multiplication. So you have like the variable x squared times x cubed. This is being multiplied. So, but let's bring everything to its base first. So this will be 5. This remains at 5 to the x. This becomes 5 square, because 5 to the square is equal to 25. And you have your 2x plus 1, and this is again 5 to the fourth power. We can drop all our bases. Now, because of the bracket here, whenever you're multiplying, the first law of indices, whenever you're multiplying terms, you have to add the power. So this becomes x plus 2 bracket 2x plus 1 is equal to 4. So let's expand this bracket here. X plus 2x times 2 is equal to 4x, and 1 times 2 is equal to 4 is equal to 4. Let's bring our 2 over there, and this becomes 5x, and we take over 2, it becomes 4 minus 2, 5x. 5x is equal to 2, x is equal to 2 over 5. 2 over 5. And that's our answer. And yes, you can get your answer as a fraction. That's not a big deal. And I think this is our final one. So we have, this looks a bit funny, but it is cool. We have here 9, which is a base, and then we have 81. This can be lowered, this 9 can be lowered to 2, I'm sure. This also can be lowered to 9, and we can work with 9. But 9 can be lowered to 3. What am I saying? 9 can be lowered to 3, because we know 3 squared is equal to 9. This 81 can be lowered to 3. We know that 3 times 3 is 9, 3 nines are 27, and 3 times 27 is 81. So 3 to the 4th power is equal to 81. So let's try that. So this is 3, and we have a square here, times 2x is equal to 1 over 3 to the 4th power. You remember the law that says whenever a term is negative, is 1 over that term to its positive power. So what we can do is reverse this here and bring the 4 to the top, and we have 3. Well, let's multiply here, okay? So we have 3x, 3, and 2 times 2x will give you 4x is equal to 3 to the minus 4. I submit to you that this and this is the same thing because we just reverse it. This is the original stage and this is the latter stage. So now we can drop the base. We have 4x is equal to minus 4. X will equal to minus 4 divided by 4. X is equal to minus 1. And that is how that is done. Let's come over here. We're going to work changing the subject of the formula. This is a topic many of you do not like. I put this in the corner here. I'm getting some noise. Let me stop. I'll